This is Johnson. Today we are going to look into a problem which is associated with an integral. And here an important thing to observe that the involvement of absolute value function in an integral. And how do we approach here, and what is the way to evaluate this? Let's see. Just brief out what it's all about. This is the symbol of integral, and these two are called limits, and this is the lower limits and that one the upper limits. This is called as an integrant, where the transformation would be taken place. This is usually in a derived form of function, and we convert this into a function. So that would be the transformation. It would take in place here, and this dx would be called as the variable of integrations. What I am going to do that I am going to break this absolute value function into a positive as well as negative function. That's how we define an absolute value function. Let's see that. Let's say if we have a modulus of x, an absolute value function, it would mean that it can be written as positive x whenever x greater than or equal to 0, and it would mean that it is also in a negative x whenever x less than 0. And if I am plugging this absolute value function into the number line, let's see how it would mean. So let's take a number line from minus infinity to plus infinity, and there is a 0. On this positive portion, the positive side, the absolute value function would mean that it takes the positive function, and at the negative side of the number line, it takes the negative function. Usually an absolute value function is called as a V-shaped function. From the positive side, it has a positive function, so which is whenever x greater than or equal to 0, and at the negative portion it takes the negative function, and when x is less than 0. So this is how the absolute function would be defined. So now coming to the integral, how do we recognize this using that definition? What are we going to do? So I am going to translate this integral into two integral using that definition. So this is how I am going to return. So integral of from minus 1, I just include a new limit 0. What you see here, this is the boundary which has a negative side from minus 1 to 0. So the boundary we have here is the negative side. We could use that and the negative function, which is minus x. So I'm using that exponential raised to the power minus x into dx plus integral of, again I use the new limit 0 to the upper limit 3. This is the boundary. It is all about from the positive side 0 to 3. So positive side we have a positive function x, and we can also write as exponential raised to the power positive x into dx. See what we see here, that both the things minus x as well as the positive x would be okay. Now it is in the standard form. We can easily evaluate this. It can be evaluated. So we know what is the antiderivative of exponential raised to the power minus x. An antiderivative of exponential raised to the power minus x is minus of exponential raised to the power minus x, which is evaluated using the lower limits minus 1 as well as 0, plus an integral for exponential raised to the power is an integral raised to the power x, which could be evaluated using the lower limits 0 as well as the upper limit 3. Now I am just pulling out the negative, not to make any confusion. Plug in 0 for x here. So if I am plugging 0, exponential raised to the power 0, anything raised to the power 0, it gives 1 to me. And if I am plugging minus 1 here, already minus is existing, minus it is positive, so exponential raised to the power minus 1, and we need to use negative here. plus, if I am plugging 3 here, exponential raised to the power 3, it is just exponential raised to the power 3, and if I am plugging 0, it is just exponential raised to the power 0. Anything raised to the power 0, it is just 1. So now we will distribute negative inside. Minus 1 minus positive, exponential raised to power 1 plus exponential raised to the power 3, and we have minus 1. So now we can conclude here. So what is our integral? It is exponential raised to the power 3 plus exponential raised to the power 1 minus 1 minus 1, we have minus 2. This is our integral. Thank you.